Welcome back to this lecture on nested quantifiers. In this fourth and last segment, we're going to give some example of translations from English to predicate logic and vice versa. So here is our first English sentence. Let's try to translate that into predicate logic. Well, we need a predicate for dogs. Let's call that g of x. And let's assume the universe for x is the set of all animals. We also need a predicate for rabbits. Let's call that r of y with the same universe as for x. And also a predicate for x chasing y, which we call c of xy. Now, let's go ahead and translate this first sentence. All dogs chase rabbits. Now, the first step is usually to analyze the English sentence and try to identify the logical connectives that are hidden in there, if any. Now, we already saw these kind of sentences. All dogs chase rabbits really hide a conditional. Namely, if you're a dog, then you chase rabbits. And this is true for every element in the universe. In other words, the sentence is going to look like, for all x, if x is a dog, then something. Now, what is the consequence of that conditional here? Well, the consequence or the conclusion of the conditional is that if you're a dog, if x is a dog, then x chases rabbits. And which rabbits? How many rabbits? Well, the English sentence is a little bit ambiguous. So notice it doesn't say that all dogs chase all rabbits, but they chase some rabbits. So here the word some is implied. At least one rabbit is chased by every dog. So what we need to do is that we need to now find a rabbit, or assume there is one, there exists y, such that y is a rabbit, and x chases it. And that is the final translation in predicate logic of this English sentence. So let me read it for you. It reads like this. For all x, if x is a dog, then there must exist a rabbit, and x must be chasing it. That is the closest predicate logic translation of this English sentence. Make sure you pause the video and think deeply about this and convince yourself that that is indeed the case. Now, for a second example, I'm going to take a slightly different tack. This sentence says, all dogs chase all rabbits. So I'm going to need two variables, one for the dogs, one for the rabbits. And notice in this case, we're dealing with all of the dogs and all of the rabbits. So I'm going to start the translation with two universal quantifiers for all x, for all y. And now I have to represent the fact that all dogs chase all rabbits. In other words, if x is a dog and y is a rabbit, then it must be the case that x chases y. So I have this condition here which says x is a dog and y is a rabbit. And if that's the case, I can infer that x chases y. In other words, for every dog x, it chases every rabbit y. Or, as it says here in predicate logic, for all x, for all y, if x is a dog and y is a rabbit, then x chases y. This third example uses the word some here instead of all. Some dogs chase rabbits. And notice in this sentence, like in the first one, the word some is also implied in front of rabbits here. So I can use a structure that is similar to the one for example 2, except in this case we're using some twice instead of all. So I could start with a double existentially quantified proposition. There exists x, there exists y. And what am I saying about x and y? Well, x must be a dog, and y must be a rabbit. And also, x must chase y. So this translation says there's at least one X and one Y such that X is a dog and Y is a rabbit, and the dog chases the rabbit. In other words, some dogs chase some rabbits. Now, notice how these last two sentences provide an example for the rule of thumb we discussed earlier, namely the fact that for all quantifiers often go with the conditional connective, whereas existential quantifier usually go with the conjunction. In particular, it would have been wrong to replace the conjunction here with a conditional, and I'll let you think about that. But for now, let's turn to our fourth example. It says, no dogs chase rabbits. Now, what would be the smartest way to go ahead and translate this into logic? I'll let you think about that for a minute. Well, it turns out, and make sure you are convinced of that sentence 4 is the negation of sentence 3. Sentence 3 says, there exist some dogs that chase rabbits. If you take the negation of that, you get, it's not the case that some dogs chase rabbits. In other words, no dogs chase rabbits. So the easiest way to translate sentence number 4 is just to copy this proposition here and put a negation in front. That's at least one way to do it. Maybe you came up with a different answer. Let's look at one more English sentence to translate into predicate logic. It says, only dogs chase rabbits. So here we have the keyword only, which seems to indicate a conditional, if you go back to our lecture on the material implication. And what this conditional states is that if you have something that chases a rabbit, then that something must be a dog. So here let's be as general as possible and says, for any two possible elements of the universe, say for any two possible animals, X and Y, if Y is a rabbit and X happens to chase it, then together that's enough to infer that X must be a dog. If something, call it X, chases a rabbit, then that something must be a dog because the sentence says only dogs chase rabbits. Again, I strongly encourage you to pause the video and make sure you agree with this translation, or maybe find a different one, but then try to convince yourself that they are logically equivalent. Now let's practice translating in the other direction from predicate logic into English. Consider this first proposition of predicate logic. It reads, there exists X for all Y, D of X and C of XY. Let's assume that D and C are the same properties and relationships that we used in the previous 5 examples. So this is saying there exists an X, and X is a dog, so there exists a dog or some dog chases Y. So that's the way the sentence is going to start. Now what is Y? Well, Y is everything because it's quantified by the universal quantifier. But by everything, we don't mean just anything in the world, like tables and apples and so on. We have to be limited by the domain of Y, which is the set of all animals. So what this is saying is that this dog chases all animals. And that is the best translation of this proposition of predicate logic. Now let's attempt a second translation from predicate logic. For all X, there exists Y such that D of X implies C of XY. So the first thing to realize is it starts in the usual way. For all X, D of X implies something. So for all X, if X is a dog, then something. In other words, all dogs, something. So what do dogs do? Well, dogs chase Y. And Y is existentially quantified, so it means some element in the universe, some animal. So in other words, the translation of this sentence is all dogs chase some animals. Now notice the only difference between sentence 6 and 7 is, one, we switch the type of the quantifiers from existential, then universal to universal, to then existential. And notice what happened in English is the word some and all just got swapped as well. But notice that's not the only difference in the logic sentences. We had to switch the and to an implication. Again, this is the same rule of thumb. If you have an existential quantifier, it usually goes with a conjunction. If you have a universal quantifier, it usually goes with a conditional. Now, what would happen if we kept the same switched quantifiers, but we used the conjunction here instead of a conditional? We'd get the following sentence. And let's try to translate this sentence into English, and I'll convince you that this sentence is completely different from this one, and probably not what you meant here. So this sentence starts with, for all x, x is a dog, and some other information. So already what you're stating now is that everything in the universe is a dog. And then you're adding some extra information that we don't even need to worry about here to realize that this is not what we meant. When you say all dogs chase some animals, you're not implying that every animal is a dog. There are also other kinds of animals, say rabbits. Whereas with this sentence, because you used an and instead of a conditional, you are actually stating that every animal in the universe is a dog. So it starts with, every animal is a dog. Now, I don't care what the second half says. It says something like, and this dog chases some animal, right here. See how the meaning is completely different and unrelated to what happens when you use a conditional. So let me conclude this lecture by mentioning that translating English sentences into predicate logic and vice versa, especially in the presence of nested quantifiers, is probably the hardest tasks that we have tackled so far. Now, I'm not going to discuss it in any more length in this course. We're going to wrap it up here. But if you were to program, say, in Prolog, which is a programming language completely based on predicate logic, you would have to master this skill in great depth. And maybe even at UWO, you might end up doing more predicate logic when you take the AI course. In AI, it's pretty common to use predicate logic to represent common sense knowledge or everyday knowledge into logic before you can process it and make some interesting decisions. But as far as this course is concerned, we're not going to go any deeper into translating from English to predicate logic.